Hello everyone, welcome back to this video series on clinical SAS TFL programming. In this video, we will discuss about the lesson which is related to creation of a summary for categorical variables with one variable as input. So we will be using sex variable as input for this table. So this video series is part of general concepts in TFL or table programming. So we'll go to the background of the table which we are going to create, and then we'll look into the input data and then followed by the program and then the intermediate data set that gets created out of the program. So the background is in clinical trials, the participants are randomly allocated to either test drug or comparator group. So we will have different groups of subjects based on the number of treatments or treatment combinations being studied in the trial. In the parallel arm study, a subject will only receive the treatment to which he or she is randomized to in the entire course of the study. To assess if the subject characteristics are similar across different treatment groups, we create summary reports. Subject characteristics can be of numeric type, say for example age or baseline BMI or baseline height of a subject, or they can be of categorical type, say for example sex, race, etc. And for categorical variables, data is summarized in terms of frequency and percentages. The percentages are generally calculated based on the number of subjects in each treatment group. So below is a table summarizing the description of sex values and the distribution of sex values, and the results are presented in a tabular format with different treatment groups presented side by side so that they can be easily compared. So here is the layout that we are going to program. So wherein we have this variable 6 and it says n, which is nothing but the number of subjects available in that particular value level of the variable. Say for example, if we are talking about this XX, so this indicates the number of males present in dose level 1, and the number that is being presented in the parenthesis is the percentage. So this represent this xx dot x on this row for male represent the percentage of males in dose level 1. So out of all the subjects who are present in dose level 1, so we have the number of males. So we divide this number with the total number of subjects who are present in dose level 1. This is represented by n is equal to xx here in the header. So that this number will be used as denominator and this number becomes numerator, and then the resulting percentage is presented here. Similarly, so all the other cells have the counts and percentages relevant in that row and column. So some of the points to note in this kind of summary table, like what is the treatment variable? The variable which contains the treatment group information is called a grouping or class or bivariable. In the above example, we are creating a summary to compare different dose levels, which are different treatment groups. The variable that contains the dose level of a subject will be called a classification variable. If we follow Adams standard, we know that the treatment values are present in either planned treatment variable or actual treatment variable, which are TRT01P or TRT01A. And these can be used as class variables when we are using Adams standard data input as input. So treatment groups are presented as columns in this report. And the other thing we need to note is how a percentage is calculated. That is what is used as denominator when calculating percentages. So in this example, we will be calculating percentages based on the number of subjects in the corresponding treatment group. As discussed, we are presenting that number of subjects present in each treatment group in the header. So that number will become denominator for all the values present in that column. Similarly, so if we see dose level 2 column, so we may have n number of subjects present here in that treatment group. That number will be used as denominator when calculating the percentages for that column. And then the next thing that we need to note is how many number of decimal values are presented in the percentages. So here in this representation, we are being asked to present one decimal for percentage. So sometimes we may be asked to present two decimals. So we need to make a note of like how many number of decimals have to be presented. And then the next thing to note is how to represent percentages when the percentage is either 0 or 100. So there can be some cases wherein there will be no subjects in that particular level. So in that case, the count will be 0. So, and there can be some cases wherein all the subjects are present in the same one level in that variable. Say for example, in treatment 1, all the subjects who are present can be males. In that case, the percentage would be 100. So there can be different notations on how we represent this, either 100 or 0 percentages. So in this example, we do not present percentage when the count is 0. So say for example, if we do not have any females in dose level 1, so we do not present the percentage component. We only present the n component and we present it as 0. And then we also need to check how to present percentage. So in this example, we'll be presenting percentage as just 100. So some others may prefer presenting it as 100.0 when the percentage is 100. Now let us go to our input data set and see how the values are like. So we have data for 5 subjects and these subjects are in dose level 1 and dose level 3. So this is in continuation with the previous lessons where we have seen summary statistics for numeric variables like age and baseline height. So in this lesson, we are building on the same example, but we have added a categorical variable to the analysis. So we have one subject in dose level 1 and 4 subjects in dose level 3. Here, the variable that we are analyzing is for sex. So the variable is called A6 because we know if we are following Adam standard, so we cannot use uh, the same named variable which is in SDTM in the Adam variable with modified values, because we wanted the analysis values to be presented as female and male in full text. But as per SDTM control terminology, in the sex variable, we'll only have the values of M and F. So we have an analysis version of sex variable created with the full text of male and female being presented in this. So if we take a look at the values present in A6 variable, on the first record it is female, on the second record the value is missing. So if we go back to the report or the TFL layout, so we had a row for missing as well. So male, female are the expected values, and in some cases the value could be missing. So for that we are summarizing the number of rows with the value is missing in the sex variable. So this row corresponds to that number. So let's go back to the input data set and then see we have out of the 5 subjects, we only have 4 subjects with uh, data available for A6 variable. Now let's move to the program and then quickly go through all the steps that we are going to use and then move to the intermediate data set that get manually created and try to understand how the flow is like. So in the first step, what we are trying to do here is process the input data set to subset only the required record. So we were asked to use generate this report on full analysis set if we see. So we are filtering only the records which have a full analysis set flag is equal to y from the input data set. And then, so we have seen in the previous example that in order to count a subject in the total column, we use this concept of replicating the rows, but differentiating the rows with a value of total in the treatment variable which we are going to create. So here in the first set of output statement, so what we are doing here is assigning the treatment variables which are the actual subject treatment values where they are randomized to whether dose level 1, 2 or 3 to the treatment variable. So we are outputting that record here, and then on the same record we are replacing the values with 4 and total. So the same subject gets accounted under the original treatment they are assigned to, and also in this newly created record with this second output statement, the subject gets accounted under total column. And then we are trying to get the treatment totals into a data set and macro variables. We'll see where the macro variables will be used. So if we come back to the description, so here the numbers of subjects in each treatment group is obtained as a macro variable and that will be used to present it in the report header. So using macro variables. So we have seen in the input data set that we only have subjects in dose level 1 and 3, but we did not have any subject in dose level 2. But as per the report, so we still need to present that column of dose level 2 and present the number as 0 where applicable. So for that purpose, what we are trying to do here is creating a dummy data set which contains one row for each treatment. So we are using a do loop and an output statement within the loop and incrementing the values of like using a comma separated list in the treatment variable. So treatment is equal to 1, 2, 3 and 4. So what this code essentially does is it this gets looped 4 times, once with first time with a value of 1, second time with a value of 2, and third time with a value of 3, and finally with a value of 4. And as we have used the output statement within the do group, so we will get those many number of records equivalent to the number of times the loop got run. So as the loop is running 4 times, we'll get 4 records in this output dataset called dummy TRT totals. And that we are getting the treatment totals based on actual data. So using procfreak. So in the table statement in this procfreak, we are using treatment. So we will get a table called output dataset called TRT total 01, and we'll get one row for each unique value present in the treatment variable. So we have rows like 1, 3 and 4 because we did not have any row for treatment 2 in the input data. So we'll get 3 rows out of this procfreak step, and those 3 rows will contain a variable called count, uh, representing the number of subjects present in each treatment. So in that output dataset, by default, procfreak gives that count in a variable called count, but we are renaming it to TRT total. And we also get a variable called percentage in the output dataset generated by the procfreak, but we do not need that percentage variable. So we are dropping that percentage variable here. And then what we are doing here is we have obtained our treatment totals based on actual data and placed it in a dataset called treatment totals. And we have created a dummy dataset which contained all 4 treatment levels. So we are now merging the dummy treatment totals and treatment totals. So we will now get all 4 levels present in the output dataset called TRT totals. So we have seen that there was no subject in dose level 2. So there will be no record in the TRT total 01, which was based on actual data. So what we are trying to do here is if a treatment is present in dummy but not in the actual treatment totals, we are assigning the treatment total to 0. And then in the next step, we are creating macro variables to hold treatment totals. So in this TRT totals, we'll have one record per treatment, and in the TRT total column, we will have the number of subjects in each treatment. So we are creating one macro variable for each treatment variable and assigning the value of TRT total to that macro variable. So when the first row is being processed wherein the treatment value is equal to 1. So what we are trying to do in the first argument of calls inputx is we are concatenating the text TRT to the value 1 in treatment variable. So the macro name of the macro variable that gets created will be TRT1 when the first row is being processed, and the value present in TRT total would be assigned to TRT1 macro variable. Similarly, for second row, we'll have a value of 2 in treatment variable. The name of the macro variable becomes TRT2. And on the TRT total present on the second row, which is for treatment 2, will be assigned to the macro variable TRT2. And similarly for third and fourth treatments. And then we are creating some utility variables for smooth processing in the downstream code. What we are trying to do here is assign a value called 1 to the group variable. So as I'm planning to replicate the same example with 2 analysis variables or 2 categorical variables in the next video, I have manually assigned a value of 1 to this group so that the same code can be reused with minimal changes in the downstream processing. So, and then I am creating a common variable called statistic and then assigning the value of asex to it when it is not missing. When the value of A6 variable is missing, I am assigning the text missing to the statistic because we have to present the text as missing when the value in a particular categorical variable is missing as per the layout. And then I'm obtaining the counts for categorical variable 6 within each treatment. So I am obtaining the counts using cross tabulation of group, treatment and statistic. So within each treatment, so we will know how many number of males and females are there in this output data set that we are going to create, and I have named it as count01. And by default, as we discussed earlier, procfreak generates a variable called percentage in the output data set that gets created, but we do not need that percentage variable. So we are dropping that percentage here using drop is equal to option. And then we have seen that we did not have data for dose level 2 at all, and there was only one record for dose level 1, and which means that so the subject would either be a male or female, and there will be no male or female in the uh, first treatment when we get the actual counts. So for that purpose, as we need like to present all the rows, even if they are present in data or not, we need to create some dummy data as per the presentation requirement and the studies data expectation. So here, as per the studies expectation, the values expected in A6 variable are female, male, or there can be some rows with missing data. So I am creating three rows, one for male, one for female, and one for missing. So based on the table presentation requirement, I need to present male as the first row within the sex variable statistics, and female as the second row, and missing as the last row. So for that purpose, I am creating a temporary sorting variable and assigning the values so that these get ordered properly. So I have used 1 for male, 2 for female, and 99 for missing. So as missing needs to be presented at the end. So I am also creating a label called sex and n percentage as per the presentation requirement in the table as displayed in the first column of the report. And then here I'll get one row per each level of sex variable values expected in the data. But I need to have these set of rows replicated for all the treatment values. So for that purpose, I am creating a do loop on the existing data set. So I have three rows here. This loop gets run once for each of the rows present in dummy01 data set, and then four rows gets created. So I'll have 3 multiplied by 4. So I'll have total 12 rows created in the dummy 02 data set. So it will be equivalent to one record per each level in sex variable per each treatment. So this is the overall structure for our table. And then what we are trying to do here is merge the dummy counts with actual counts. So here we have obtained the counts for each of the level present in sex variable in each treatment, and we have put them in a data set called count01. And here we have created that full template where we have all the levels which are expected in sex variable and all the treatments. And then we are merging those two data sets here at group, treatment and statistic level. And we have seen that there can be some cases where the particular level in A6 variable may be absent in the data. So in such cases, if a record is present in dummy but not in the actual data set, we are assigning a value of 0 to the count data set. And then next we need to do is calculate percentages. So how do we need to calculate percentages? In this example, we were told that we need to use number of subjects in each treatment as the denominator when calculating the percentages. So we have already obtained that numbers into a data set called TRT totals. So we need to fetch the TRT total into our counts data set so that we have count, which is our numerator, and the denominator side by side so that we can calculate percentages. So in order to calculate the percentages, we need to fetch the treatment totals into the data set containing counts. So we are making use of our merge concept to achieve this. And then we are creating the percentage variable and concatenating the count and percentage into a single variable. So here if you see, we are calculating the percentage when the TRT total not is equal to 0. So we are checking whether the treatment total is not 0 because If we do not check for this, we are trying to divide the number with 0. So if we have TRT total is equal to 0, that will become the denominator value will become 0 here. So when we are trying to calculate the percentages, SAS throws us a note when we are trying to divide any number with 0, because as 0 division is not possible in the computing environment. So we are trying to skip that note which SAS provides by explicitly passing or calculating the percentage only when the denominator is not 0. And then we are trying to create a variable called CP, which stands for count and percentage in short, and concatenating the count and percentage. As we discussed, like there can be cases wherein the count itself is 0. So in that case, we were asked to present only the count and not the percentage. So we were checking if count not is equal to 0 and else true. The else of count not equal to 0 would be count is equal to 0. When the count is equal to 0, we do not need to represent percentage. So we are only assigning the count directly to the CP variable without concatenating the percentage. But when the count is not is equal to 0, and we are have two cases. There can be cases where percentage is 100 or not 100. So when the percentage is not equal to 100, we are representing the percentage in one decimal with 5.1, and then concatenating that percentage value within the parentheses and concatenating it to the count value. Else, when the percentage is 100, we are just presenting it as just 100 without any decimal. So if we had not used this, and if we had used 5.1 for all the cases irrespective of the value in percentage, so even when the percentage is 100, we would have presented the percentage as 100.0 instead of 100. So we are handling the presentation requirement of 100 percentage with these two lines of code. And then we have our counts and percentages collected. In this processing so far, we still have the treatment values available as rows. So we need to have them as columns. So we are employing a proc transpose to transpose the count and percentage value with treatment values in the ID statement. So the treatment values will become, which are appearing as rows in the input data, will now become columns in the output dataset, which is count05. Similar to the previous lesson where we have used prefix is equal to option to rename the newly created variables, we have used again here TRT as prefix. So the newly created column names would become TRT1, TRT2, TRT3 and TRT4. And then in the final step, we are keeping only required variables which are used in reporting. So in the proc report step, so when compared to the previous lesson, what we have done in addition is, in the previous lesson where we have created summary statistics for numeric variable, we did not add the number of subjects in the header. So but here we are adding it. So we have already created macro variables which contains the number of subjects in each treatment with the same names as TRT1, 2, 3 and 4. So here we are making use of those macro variables to present the number of subjects in the header. Now let us move to the data sets that are getting created out of this code. So in the first step is our input data set, which is ADSL. We had 5 rows. The, out of the total possible treatment groups of dose level 1, 2 and 3, we only have data for 1 and 3, which means there are no subjects in dose level 2. And out of the subjects in dose level 3, so we have one subject with missing value in A6 variable. So in the next step, what we have done is we have filtered the rows where FASFL is equal to Y. As all subjects had FASFL is equal to Y, this would be equivalent to the input dataset which we had. And then in the next step, what we have done is replicated the rows for accounting a subject under total column. So here this is subject 1001. So we have replicated the subject the second time, so with a value of total in the treatment variable, whereas in the first record we use the value from TRT01PN and TRT01P for treatment and treatment C variables respectively. So this row, the subject is getting accounted for the dose level he or she is being randomized to, and the second record, the subject is getting contributed under the total column. So similarly, this is the case for other subjects. And then we have created our dummy TRT totals. So wherein we have used a do loop saying that do treatment is equal to 1, comma 2, comma 3, comma 4, and then used an output statement within the loop. So we created this data set which only had treatment variable, but all four treatment levels expected to be displayed in the report. And then we fetched our treatment totals based on the actual data. So we have seen that we had only dose level 1 and 3 in the data, and then we have replicated the rows for total. So we have 1, 3 and 4. So when we run the proc freak for treatment variable, so we got the data, or the output data set only had rows for the treatments which are available in data 1, 3 and 4. So this means there is one subject in treatment 1, then there are 4 subjects in treatment 3, and then this 4 is nothing but our total. So there are 5 subjects in the input data set where FASFL is equal to Y. So, but we need to present that treatment 2 is equal to 0 as well in our reporting at the end. So for that purpose, what we have done is we have merged this treatment dataset to the actual dataset at treatment level. And if a record is present in dummy dataset, if a treatment is present in the dummy dataset but not present in the treatment total 0 1 dataset, what we have done is assigned the value as 0. Now in this dataset we have all treatments, and we have also have that number of subjects available in the absent treatment as 0. So this dataset can be used in when calculating percentages and also when creating the macro variables. In fact, we have used this TRT totals dataset and then created our macro variables using the calls input logic. We have concatenated the text TRT to the value in treatment variable, which become TRT1 here, TRT2 here, TRT3 and TRT4. And on all those 4 rows, we have used the value from TRT total and assigned it to the macro variable that gets getting created. For example, on this 4th row, the name of the macro variable would have become TRT4, and a value of 5 which is present in the TRT total variable would be assigned to TRT4. And then we have created some utility variables. So that was one was group variable and the second one was statistic variable. So wherever A6 was not missing, we have assigned it as a copy to the statistic variable, and whenever it is missing, so we have assigned the text missing to this statistic variable. And then we have obtained the frequencies based on actual data. So and we have stored them in a data set called count01. If we see under treatment 1 female, there is one subject, and under treatment 3 female, there is one subject. Treatment 3 male, there are two subjects. Under treatment 3, which is dose level 3, there is one subject with missing value in sex variable in statistic, and similarly is the case for total. So we now see that we only have levels which are present in data is being obtained with the output data set in proc freak, but we need to display zero counts in the rows where they are absent. For that purpose, we have created this dummy dataset to contain all the levels male, female, and missing, and we have used a sorting variable to indicate to use in sorting requirement in the proc report. And then we have replicated all 3 possible levels in sex variable for each treatment. So 3 treatments, and then we have replicated it for female, male, missing for first treatment, and then female, male, missing for second treatment, female, male, missing for third treatment, and similarly for fourth treatment. So we have replicated each treatment, each level for all the 4 treatment levels. And then we have merged our dummy dataset with the actual counts which were present in count01, and then assigned a value of 0 when the row is present in dummy dataset but not present in the actual dataset. So now we have full template representing or containing the numbers as zeros when a level is absent in the input dataset. And then we have to calculate our percentages. So for that we merged our treatment totals and fetch the treatment total value into our counts dataset. Now we have the numerator which is count and the denominator which is TRT total side by side. So we can calculate percentage easily. So in the next step we have calculated percentages, and we have also calculated we made sure that we are calculating percentage only when the denominator is not 0. So here in this case denominator is 0. So we have not calculated percentage in that cases. If we had tried to calculate percentage without checking whether TRT total is equal to 0, SAS would have thrown a note to the log saying that division by 0 has occurred. And then we created this CP variable concatenating the count and percentage. So we created CP as only count, uh, maybe let me put it this way. So we created CP variable to present only the value in count variable. So when the count is 0, otherwise when percentage is present, we concatenated the count value and the parents, and within the parentheses we presented the percentage. And when the percentage is 100, we have used 3 dot so that we get the number as 100 instead of 100.0. If we had used 5.1, even when the percentage is 100, so we would have got a value like 100.0 here in the CP variable percentage component. So now we have our CP variable created with count and percentage concatenated into a single value. And in the next step, what we have done here is we have restructure the dataset that the treatment values are becoming columns as per the table presentation requirement. So till this step we have all the treatment values appearing as rows. So now we have restructured the data such that a column is created for each treatment instead of appearing as in previous row. So we achieved this result using proc transpose by specifying prefix is equal to TRT on the proc transpose statement, and also on the ID statement we specified the variable treatment, and on the var statement we have used CP. So we now have the final structure, and we kept only the variables which are required for the final table presentation requirement, and then we generated the report using proc report. Now let's go back to the report that we have generated. So we have seen that, so in the proc report code we have added that n is equal to ampersand trt1, trt2, ampersand trt3 and trt4. So we had one subject in dose level 1, so we have now accurately represented that number in dose level 1. So we did not have any subject in dose level 2 in our input data, so we have this represented as 0 in the header and also in the individual levels. So dose level 3 there are 4 subjects, so we have got it represented correctly, so using ampersand trt4, and total there are 5 subjects. So one thing to note here is there was one subject who had a sex variable value missing in the input dataset, and he or she was in dose level 3. So now we have that correctly represented under missing row 1, and the percentage is 1 divided by 4, which is 25%. So this is how we can create a summary table for categorical variables. Thank you for watching. Keep learning.